Welcome. Today we're going to do combinations. Whoa, that was weird. Combinations, which is our last section in chapter 7, and also the last topic that will be on test 2. So let's get started. From last week, or I guess kind of this week because I'm recording it now. If you have letters A, B, C, for example, and you have to make a 2-letter word sequence, okay, then we said, okay, well, then I can make AB, I can make BA, BC, CB, AC, CA, right? And these are all the different permutations. Okay, and so now I have, let's see here, 6 permutations. And one of the ways that we could find that was by using our slots, right? And so at first I'll do it backwards, 3 letters to choose from, and then I have 2 letters left, right, from A, B, C. Now, today, what we're going to talk about is a scenario where what if we have a group of 3 people, A, B, C, Al, Bob, and Chris, okay? And we want to make committees of 2 people each, okay? Now, I want you to think about the difference between what's going on here with AB, BC, and CA versus here AB, BA, right? BCCB, ACCA, okay? So here, these guys are kind of lumped together, and these guys are kind of lumped together, and these guys are kind of lumped together. And if order doesn't matter, right, then we would just summarize these two, A, B, B, A, as AB, right? And we would just say, well, a committee, right? So a group of 2 people that has Al and Bob is going to be the same group as Bob and Al, right? And so the group is the same. Okay? And so that's what we're going to work on today. Okay? And so when we're forming committees or just groups where the order doesn't matter, okay? And so this is the important part, right? When forming committees, the order is not important, okay? Because the committee that has Al and Bob is no different than the committee that has Bob and Al. Okay, so a group with Al and Bob and Al, it's the same group. Okay? And so what that means is that we have now 3 committees instead of 6. Okay? And so here, now we have 6, or sorry, trip you up. 3 combinations is what we're going to call them. Okay. When we're talking about word sequences where the order of the letters matters, then we're talking about permutations. Whereas if we're forming committees or groups, right, then we're talking combinations. Okay? And so that's what we're introducing today, kind of this new idea. Now, permutations are arrangements where order is important. Okay? And I want to highlight this one. How can I highlight something extra? Is that too dark? Can you still see? Let's see. How about orange? Combinations. So permutations are arrangements where the order is important. Okay. So things like words, right? Different words. First place, second place, third place, right? Those kinds of things. And then combinations are arrangements where order is not significant or not important. And so what that means is if you just have a group of 5 people, right? Doesn't matter how you got there, right? Then you do a combination. Okay? It's going to be important to be able to pick those apart because we need to figure out which formula we need to use. Okay. And so, as an example to start us off with, I kind of altered it a little bit. But if you have 4 letters, A, B, C, D, okay, and I want you to write the combinations, not just the number of combinations of 3 letters, but actually write them out, and I've got them kind of pre-baked. And then from these combinations, determine the permutations. Okay? And so if order doesn't matter, then if we're making 3-letter combinations, right, then I could go A, B, C, that's my first one. I could go B, C, D, that's my second one. I could go C, D, A, which is my third one, or the last one would be B, D, A, right? And just make sure that you've caught all combinations of 3. Okay? And so these are what we call combinations, or these are the combinations. Here, oops, I shouldn't have drawn that line like that. I should have drawn it like this. Okay. Now, from each of these, what we can do is we can write out, okay, well, if order matters, then I could rearrange this and write BAC, BCA, CAB, right? And I'm not gonna do it because I've already done it here, but let's talk about them. Okay. So from ABC, I can create a CB, BAC, BCA, CAB, CBA, and so on and so forth. So from each of these 4 combinations, right, each combination yields 6 permutations. Okay? And so here we get 6 permutations for each combination. Which means that there would be a total of 24 permutations, right? And so, and we can find that, right? And so the total permutations, oops, from before, that doesn't look like an O, permutations is going to be from sure. Let's do, I'm trying to decide if we should use the formula. Maybe we'll practice using the formula on your formula sheet, right? Which got somewhere here. So from n items, so letters in this case, so 4 letters, we're going to permute or arrange them in groups of 3. Okay? And so from 4p3, 4 factorial over 4 minus 3 factorial. Remembering that 4 factorial divided by 1 factorial is just going to be 4 factorial, which is, just as a reminder, because we'll need the factorials today again, 4 times 3 times 2 times 1, right? Decreasing, starting at 4, you decrease by 1 until you reach 1. Okay. notice, and this is why I wanted to use the formula, notice that this is the same as if you did your slots, right? Should only have 2 slot or 3 slots there, but the answer is the same. Huh? And so, right, from 4 things, A, B, C, D, and I want to make groups of 3, then I have my first letter, I have 4 choices, second letter, I have 3 choices, and then my third choice, I have 2 choices left. Okay, or my third letter, I have 2 choices left. Huh? And so you get the same answer. Huh? Which is 4 factorial. See if you have a factorial button on your calculator, but you'll find it should be 24. A lot of calculators have a factorial button. Okay. Okay. Good. Now, I'm trying to remember because clearly I left myself some space here. Let's talk about combinations. What was I gonna say? Drawing a blank. That's all right. How do we get to 4 combinations? Well, that's what it was. Well, if I have, let's see here, ABC, how many permutations do I have here? Right, so I have a 3-letter, I have 6 permutations. Okay. In fact, I would have 3 factorial combinations, which would be 3 times 2 times 1, which is equal to 6 permutations. All right, why is it 3 factorial? Well, if I tell you, hey, you have a group of 3 letters, right, and I want you to make as many 3-letter combinations or permutations, I should say, as you can, right? Then you would have 3 choices for the first letter, then 2 choices for the second letter. I think you see where this is going, and then 1 choice for the last letter, right? So it's kind of a subgroup of the first one. Notice we have 24 divided by 6 combinations, which is 4. Oh, still can't remember what I was going to put there. I had something in mind. That's okay. Just introduce the formula instead. Maybe I'm just more efficient this time. No. Combinations. So a combination of a set of elements is an arrangement where the element is used once and the order is not important. Okay? So I really want to emphasize that because that's the only way that we're going to be able to determine if I need a permutation or a combination. So the number of combinations of n objects taken r at a time is going to be NCR, which you also have an NCR button on your calculator. And so I encourage you to try to find it, okay, because it might be nice to be able to check your work. And it's n factorial divided by n minus r factorial times r factorial. Okay, and so I'll say most calculators have an NCR button. Oh, now I remember what I was going to fill the space with. Maybe I'll move this down since I remembered. Put it there. Huh? This is the same as the number of combinations, the NPR divided by R factorial. Okay. Now, this is going to be I'm regretting it. I think it's going to be one of those things. We can just take it at face value. Anyways, you can ignore this next little tidbit. I'll wake you up when it's over. NPR from our formula sheet, right, is n factorial over n minus r factorial, right? So I have n factorial divided by n minus r factorial. Then I want to divide that by r factorial. Now, technically, I can create a fraction over a fraction, right? And so here, technically, r factorial is r over 1. And so what we can do is we have n factorial over n minus r factorial times 1 divided by r factorial. Okay. And so how we get the NCR calculation is this. Okay. Multiplying fractions, I'm allowed to multiply across, and just to keep it in the same area here, this becomes n factorial over n minus r factorial times r factorial. There. Now you have to wake up again. You don't have to know how that evolved, I should say. But that's how we get this formula. N factorial over n minus r factorial times r factorial. Okay. But like I said, most calculators have an NCR button, but just like we saw before, I want you to be comfortable canceling factorials, right? And so let's do a couple of examples here. I want you to compute using the formula, okay? 5C3 and 7C3. Okay? How I read the C is I read it as choose, right? 5 choose 3 and 7 choose 3. Okay? And on your formula sheet, which I really gotta put a mark on here so it bumps it up to the top. Hey. Now, if we're calculating n choose r, right? Then we need to do n factorial over n minus r factorial times r factorial. Okay? And so using the formula, now what's nice is you'll be able to check your work with a calculator, right? Just double check. But I want you to be able to manipulate the formula. So starting with 5 choose 3, that is going to be the same thing as 5 factorial divided by 5 minus 3 factorial times 3 factorial. Now the trick here, because we already know the trick of writing out the 5 factorial until I hit what's in the denominator, and then I'll be able to cancel. Now what you want to do in the denominator is first you want to simplify. So 5 minus 3, okay, is 2 factorial and 3 factorial. 3 factorial is bigger. So I'm going to write out 5 factorial until I get to 3 factorial. Okay? Let's do that. So here, 5 times 4 times 3 factorial divided by 2 factorial, 3 factorial. Okay? And so here, I'll just make a note. Write out 5 factorial until you reach the larger factorial in the denominator. Until you reach the larger factorial in the denominator. And that's just to cancel as quickly as you can. Okay. Because now 3 factorial divided by 3 factorial, because it's all multiplying and dividing, that's why I'm allowed to cancel. Now I have 5 times 4 divided by 2 times 1, technically, right? And so I have 20 divided by 2, which puts me at 10. And I encourage you to try to figure out your calculator. 5, choose 3, I do get 10, right? So here, I encourage you, I encourage you to check your answer with a calculator. No? But I do want to see those cancellations of the factorials, right? And writing out and showing me that you understand what a factorial is, right? And so 7, choose 3. Let's do that one. Because it's on a new page, n factorial divided by n minus r factorial. 7 is my n and r is my 3. And so 7 factorial divided by 7 minus 3 factorial times 3 factorial. Simplifying that 7 minus 3, this is going to be 4 factorial, right? And so 4 factorial is bigger than 3 factorial. So I'm just going to write out my 7 factorial until I hit 4 factorial. So I get 7 times 6 times 5 times 4 factorial. Divide by 4 factorial, 3 factorial. Now, my goal was to cancel something, and I canceled 4 factorial. Now I have 7 times 6 times 5 divided by 3 factorial, which is 3 times 2 times 1. Okay. And so 7 times 6 times 5 is 210 divided by 3 times 2 times 1, which is 6, puts me at 35. Okay. And again, I'm just going to check. 7, choose 3 is 35 on my calculator. Nice. Okay. So sometimes, as you know, we have to solve some word problems and figure out if I need to solve permutations or combinations. And so here's some examples. In how many different ways can a student select to answer 5 questions from a test that has 7 questions? Okay. If the order of the selection is not important. Okay. And so just to lay it out, I've already written it out here, but question number 1, 2, 3, 4, 5, 6, 7. And if you pick 5 to submit, right? So you're picking 5 questions that you're going to answer. Then let's say you pick 1, 2, 3, 4, 5, right? That would be the same selection as 3, 2, 4, 5, 1, right? You can just rearrange the order and then hand them in, and to your instructor, it would be the same thing, right? And so what that means is from 7 things, choose 5. Okay? And so what we have is we want to find 7, choose 5. So from 7 things, choose 5. Now you can use your calculator, but let's just practice our 7 factorial divided by 7 minus 5 factorial times 5 factorial. 7 minus 5 factorial is 2 factorial, so I'm going to write out 7 factorial. Oops, not factorial. 7 times 6 times 5 factorial divided by 2 factorial, 5 factorial. Dink, dink. Now 7 times 6 divided by 2. Technically 2 times 1. I get 21. Yeah. Check that on your calculator. 7, choose 5. 21. Phew. Nice. This next one is a little bit sneaky. I've gone ahead and drawn out the scenario, and so how many line segments can be drawn by connecting any two of the 6 points that lie on the circumference of a circle? So let's say you have A, B, C, D, E, F, right? Then I have 6 points on a circle. Okay. Now, if we think about a line segment, okay, such as AC, okay, line segments are just combinations of 2 letters because the line segment between from A to C is the same as C to A. Okay? And so that makes it a combination because the order that I do it in, it doesn't matter. It generates the same line segment. Okay? Same thing if you wanted to go from C to F or F to C, it just does the same thing. So what we can boil it down to is something that we've seen before, right? So from A, B, C, D, E, F, so 6 points on a circle, okay? How many combinations of length 2 do we have? Okay? And so what we want to find is we want to find 6, choose 2. 6, choose 2 is 6 factorial divided by 6 minus 2 factorial, oops, times 2 factorial. 6 minus 2 factorial is 4 factorial. So what I'm going to do is I'm going to write out 6 times 5 times 4 factorial is 4, or divide by 4 factorial, 2 factorial. That's going to cancel. 6 times 5 divided by 2. Let's see here. 15. Now I'm going to check 6, choose 2 on my calculator with the choose function on the calculator. I get 15. Oh. Nice. Here's a fun one for your next party, I guess. There are 10 people at a party, and if they all shake hands, how many handshakes are possible? Uh, so how I want to kind of illustrate this is, well, if Al shakes hands with Bob, that's going to be the same handshake as Bob shaking hands with Al, right? And so again, we have this combination where the handshakes, right? It's just 2 people shaking hands and it doesn't matter which order. In fact, there is no order, right? And so, so again, from 10 people, right, I want to choose combinations of 2, assuming it's a 2-man handshake. They didn't specify, but I think it's safe to assume. Okay, so what we want to find is 10, choose 2. 10, choose 2. is 10 factorial divided by 10 minus 2 factorial times 2 factorial. 10 minus 2 is 8, right? So I'm going to write out 10 factorial. Oops, sorry, not 10 factorial. I keep doing that. Times 9 times 8 factorial divided by 8 factorial 2 factorial. Now, 8 factorial over 8 factorial is going to cancel. And 10 times 9 divided by 2, I'm going to go with 45, but let me confirm. 10, choose 2, 45. So 45 handshakes are possible. So that's kind of a fun one, right? Because I think it's relatively easy, right? How many people are there? And from that number, choose 2, right? And then you'll be able to figure out how many handshakes there are possible. Okay. So this one is kind of sneaky, but let's break it down. The shopping area of a town is in the shape of a square that's 5 blocks by 5 blocks. And so what I've done is I've already drawn out the 5 blocks by 5 blocks. Okay. How many different routes can a taxi driver take to go from one corner of the shopping area, let's say from A, to the opposite cater corner? I've always thought it was kitty corner, but I guess it's cater corner. I don't know. But the opposite side. Huh? So what we can do is we can break this down and we can say, okay, well, we have to move in order to go from A over to B, right? Then we're going to have to move up or north or vertical, all the same meaning, right? So moving this way, some number, and moving this way, some number. And so what you can do is you can think of it as, okay, well, there's a couple of different routes, right? You could go up 5 and then over 5, right? You could go up 1, over 1, up another one, over another one, up another one, over another one, up another one, over another one. Go this way, mix it up, get crazy, right? Just so I didn't overlap the yellows. So there's lots and lots of different ways, but what you would find, if you think about it, is that all of them would require you to move 5, well, let's start with the 5 vertical, right? You'd have to move 5 up 5, right? Because no matter how you get there, you have to move up 5, right? And you'll have to move 5 horizontally, so you'll have to move over 5 horizontally. Okay, and so what you could do is you could say, hey, what if I move 4 horizontally? Let's talk about what that looks like. 4 horizontally, 1, 2, 3, 4. 1 vertical, another horizontal, and 4 vertical, right? That's another option. Okay, and so what we have is we have, sorry, let me close that. Right, we'll always need to make 5 vertical moves and 5 horizontal moves. Okay? Now, what's neat is if you say, okay, I am going to definitely go up this one, I'm going to go up on this one, and I'm going to go up on this one, and then I'm going to go up on these 2 here. All right. That also predetermines the horizontal moves that I would need to make. Right? That's not obvious. That's kind of advanced, right? But so if I start with this segment and I'm trying to move to this segment here, then of course the only way that I could get there is to move these two horizontal moves. And from this segment, if I want to move over to, where did I draw this one? Here, this segment, right? Then it predetermines that I need to move these horizontally. And if I want to move from here to here, these guys, then of course I need to use this segment here. Okay. And so that's kind of neat that we only need to pick the 5 horizontal or 5 vertical, it doesn't matter, blocks, and then the remaining 5 will follow. Which means, right, that we have, let's see here, 10 choose 5. Sorry, I have to just pause it just a sec. Yeah, sorry. Too distracted. 10 choose 5. That's what we were saying. So, because 5 horizontal, 5 vertical, and I need to choose 5 of those to be to be horizontal or vertical. It actually doesn't matter, as we saw. 10 choose 5. It's 10 factorial divided by 10 minus 5 factorial times 5 factorial. Now, I have 5 factorial times 5 factorial in the denominator, so that's not going to save me a ton of work, but I will cancel just like we have been doing. So 10 times 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial, 5 factorial. Now you have to be careful because only one of those 5 factorials is going to cancel. Okay? And 5 factorial itself is, if you don't have a factorial button, then I'll write this out again. 10 times 9 times 8 times 7 times 6 is 5 times 4 times 3 times 2 times 1. 10 times 9 times 8 times 7 times 6. I get 30240 divided by 5 factorial, which is 120. 30,240 divided by 120, I get 252 different routes that you could take. And I want you to confirm 10 choose 5 is 252 on your calculator, which it is. Nice. So that one's a little bit sneaky just because, right, unless you've seen one before, which you have now, right, where you say, I've seen a scenario like this before where, okay, I've got these blocks and I want to move over, right, and I total moves 10, right? And so here, 10 total moves. I should have clarified that earlier, I guess. Where 5 have to be horizontal and 5 have to be vertical, and if you just choose 5 horizontals, the other 5 will follow, right? Because they'll be determined. If a coin is tossed 6 times, in how many ways can it fall 4 heads and 2 tails? Okay. And so let's see here. So I toss it 6 times and I want 4 heads and 2 tails. Okay. Now here's the thing. If I toss it 6 times, and I force 4 heads, right? So from 6, I choose 4 to be heads. Then, of course, if only 4 are heads, then 2 have to be tails, right? And so what we'll find is that we'll notice that we could do 6 choose 4 versus 6 choose 2. Let's do them side by side. Okay. So 6 choose 4 is going to be 6 factorial divided by 6 minus 4 factorial times 4 factorial, which is 6 times 5 times 4 factorial, divided by 2 factorial, 4 factorial. Oh, cancel those guys. And I'm left with 15. How about 6 choose 2? 6 choose 2 is 6 factorial over 6 minus 2 factorial, 2 factorial. Already you probably notice that these are looking kind of similar, right? And so 6 factorial, oh, sorry, not 6 factorial. 6 times 5 times 4 factorial divided by 4 factorial, 2 factorial. Different 4 factorial cancels, but the result is the same. All right, I get 15. So notice we get the same answer since 4 heads in 6 tosses means there must have been 2 tails. Means there must have been 2 tails. And vice versa. So very similar to the taxi route, right? If you force 4 heads, well, in 6 tosses, if you only have 4 heads, then the other 2 have to be tails. Okay. Well, as promised, I guess it's the shortest video you'll ever have to watch, probably. So this is the end of chapter 7. Nice work. Also, end of test 2 material. I don't have room to write that, but because there's a page break. But now you'll have all the knowledge for test 2, and I hope you enjoy the break and see you in class.